in this lesson, we are going to talk about ratios, proportions, and the geometric mean. We're going to split this into two different videos, ratios and proportions in this video, and the next video we'll talk about the geometric mean. So a ratio is a relationship between two quantities. A ratio can be written as a fraction. And for that reason, any number that can actually be written as a fraction is called a rational number. Notice that root word ratio. So any fraction is a ratio, so any number that can be written as a fraction is called a rational number. Each number in a ratio must be written in the same units. Okay, so it could be measurements like feet over feet. It could be weights like pounds over pounds. If the units are different, then it's called a rate, and we'll use those later on. So a ratio of A to B can be written like this, A to B, or it can be written as a fraction, A over B. A ratio of B to A is different. Whatever is listed first goes first or goes in the numerator. So a ratio of B to A looks like this or like this, where B comes first or B goes in the numerator. So we've got some ratios that we want to simplify. 76 centimeters over 8 centimeters. So if we write it as a fraction, 76 over 8, okay, that can be simplified. So 76 over 8, and we'll just use the calculator to simplify this for us. So 76 over 8 is 19 over 2. Okay, so that fraction simplifies to 19 over 2. Now, it started in this form, so I'm going to write my final in this form. So 19 centimeters to 2 centimeters is my simplified ratio. Okay, the next one, 4 feet to 24 inches. This one is actually not written as a ratio, it's written as a rate. And I want to put these into the same units. Okay, so we can change both to feet or both to inches. Let's do inches. So if we change this to inches, remember there's 12 inches in a foot. So if I multiply that number by 12, I'll get the number of inches. So 4 times 12 is 48. So I can change that to 48 inches over 24 inches. Okay, now we can use the calculator to simplify this if we want to, but 48 over 24 is 2 over 1. So it's 2 inches over 1 inch. And this one started in the form of a fraction. I will end it in the form of a fraction, so this is my final simplified ratio. Okay, here's a couple more ratios to simplify. 4 meters to 18 meters. Now this one is just written with the word 2. Okay, so we're going to write our final answer just like that. But first, I'm going to write 4 over 18 as a fraction, and I'll simplify that. So 4 over 18, and 2 goes into both of those. 4 and 18, 2 times and 9 times. So we get 2/9 as our simplified fraction. So the simplified ratio is 2 meters to 9 meters. Okay, the next one, 33 yards to 9 feet. Okay, these are different units, so I need to change that. Now, there are 3 feet in a yard, so I can change both to yards or both to feet. I'll do both feet. So 33 times 3 will give me the number of feet, so that's 33 times 3, that's going to be 99. So we get 99 feet. So it's 99 feet to 9 feet. Okay, and I can write it as a fraction, or I can just picture this as a fraction in my head. 99 over 9, that's 11 over 1. So 11 feet to 1 foot is the simplified ratio. So you're going to paint some barn doors. And the perimeter of the doors is 64 feet. So let's draw a rectangular set of barn doors. And I know the perimeter is 64 feet. So perimeter, that's the distance around these doors. All four sides add up to 64 feet. And the ratio of length to height of the doors is 3 to 5. Now I don't know the length and height of the doors, but I know they're in a ratio of 3 to 5. So that's length to height, which means that they're actually taller than they are long. So I didn't really draw it quite to scale here. Okay, length to height is 3 to 5, so I'm going to do 3x and 5x as my length and my height. Okay, and that means this is 3x and this is 5x. Find the area of the door. So we're going to find out what x is and then use that to find the area of the doors. So the perimeter comes from adding all four sides together. So we have 3x plus 3x plus 5x plus 5x, and that will give me the perimeter. And I know the perimeter is 64 feet. So I can combine like terms. I've got 3 and 3, that's 6. 5 and 5 is 10. So when I put that all together, I have 16 x's equals 64. And I can divide by 16 and get x equals, so 64 divided by 16. And that is 4. So x is 4. So I have 3 times 4, which is 12, so this is 12 feet. And 5 times 4 is 20, so these doors are 20 feet high and 12 feet wide. Now the area of a rectangle is length times width. So the area of this set of barn doors is 12 times 20. Okay, so 12 times 20 is 240. Okay, and that's the area of the door, and area is in units squared, and these are feet, so it's 240 feet squared for the area of these doors. Okay, so here's a similar problem. The perimeter of a rectangular table is 21 feet. And the ratio of its length to width is 5 to 2, so 5x and 2x. Okay, find the length and width of the table. So this time I'm not asked for the area, just the length and width. So where we got the 12 and 20 here, that would have been the place we would stop if we're just looking for the length and width. So for the perimeter, I can do 5x plus 5x plus 2x plus 2x. And that equals 21. Okay, so that's 5 plus 5 plus 2 plus 2, and that is 14. So 14x equals 21. And divide by 14. So I get x is 21 divided by 14, 1.5. So x is 1.5. So the length is 5 times 1.5. So length is 5 times 1.5. The width is 2 times 1.5. Okay, so 5 times 1.5 is 7.5. So the length is 7.5 feet. And the width, 2 times 1.5, is 3 feet. So the dimensions of this table are 7.5 feet by 3 feet. The measures of the angles in triangle BCD are in the extended ratio of 2 to 3 to 4. It's called an extended ratio because it's longer than a normal ratio. It's extended to an extra spot here. Find the measure of each angle. So this triangle BCD has angles that are 2x, 3x, and 4x. This may not be drawn to scale, and that's okay, but I've got my three angles at 2x, 3x, and 4x because of this ratio 2 to 3 to 4. So if I add those together, 2x plus 3x plus 4x, I know that the three angles of a triangle have to add up to 180. 2 plus 3 is 5, plus 4 is 9, so 9x equals 180. And divide by 9, so I've got 180 divided by 9, and that's 20. So x is 20. Okay, find the measure of each angle. So my angles are 2 times 20, 3 times 20, and 4 times 20. Okay, so 2 times 20, that's 40 degrees. 3 times 20 is 60 degrees. 4 times 20 is 80 degrees. And let's just check that. 40 plus 60 plus 80 adds up to 180. So my numbers are correct. So these are the three angle measures of this triangle. Okay, another one like that. This time the angles are 1 to 4 to 5. So 1x, 4x, and 5x. So I have 1x plus 4x plus 5x, and that has to add up to 180. Okay, so 1 plus 4 plus 5, that's 10. 10x equals 180. And I will divide by 10. So x is 18. So I have 1 times 18, 4 times 18, and 5 times 18 for my three angle measures. Okay, 1 times 18 is 18. I don't think we need a calculator for that, but we could pull one out for 4 times 18. 72 degrees, and 5 times 18 is 90 degrees. Okay, now let's check this out. 18 plus 72 plus 90, I hope that's 180, and it is, so that means my three angles are good. Okay, now proportion. A proportion is an equation that states two ratios are equal. Okay, so a ratio like A over B set equal to another ratio like C over D. Okay, so that's a proportion. Anytime one ratio equals another ratio, or one fraction equals a fraction, you have what's called a proportion. Okay, in a proportion, the means are this secondary diagonal here, B and C, the extremes, A and D. And in our next lesson, we'll learn something that we can do with those means and extremes. But the first thing we need to know about proportions is the cross products property. In a proportion, the product of the means is equal to the product of the extremes. I don't need an A there. What am I doing? It would help if I could spell words that were literally right in front of my face right here. So, if A is to B as C is to D, then I can diagonally multiply, so cross multiply. So A times D is equal to B times C. Okay, so we are going to use that cross products property to solve some proportions. So I have 3 is to 4 as x is to 16. I can multiply 4 times x, and I can multiply 3 times 16. Okay, so let's use the calculator for that. 3 times 16 is 48. Okay, so that's the cross products property. Now I can just divide by 4, and 48 divided by 4 is 12. Okay, so here's another proportion. This one's got a little bit more to it though. So I've got 3 times x. It doesn't matter which diagonal I do first. I'll do this one, 3 times x, and then 2 times x plus 1. Okay, and I'm going to have to distribute in this one. Okay, so I get 3x equals 2x plus 2. Now I can subtract 2x and get 1x equals 2. Okay, now let's apply that. You want to know the numbers of rows of boards that make up 24 lanes at a bowling alley. So you know a bowling lane has all these different rows of boards in it. And we want to know how many rows of boards it takes to make up the 24 lanes at a particular bowling alley. Okay, so if you start just counting these boards, you're going to get pretty tired of counting. But after you get through 3 lanes, you've counted 117 rows of boards. So let's use that to find out how many rows of boards it takes to make up the 24 lanes. Okay, so it takes 117 rows to make 3 lanes. Okay, so how many rows does it make, or does it take to make up 24 lanes? Okay, so it's 117 rows to 3 lanes. How many rows to 4 lanes? So I'll make a note here that I've got rows on top, 117 rows, x rows, and I've got lanes in the denominator here, 117 rows for 3 lanes. How many rows for 24 lanes? So now cross multiply. 3x equals 24 times 117. I don't know that one off the top of my head. So 24 times 117 is 2,808. Okay, and if I divide by 3, I get 936. So it takes 936 rows of boards to make up the 24 lanes. Okay, a few more practice problems and we will be finished. So we've got a proportion here. We'll cross multiply. 2 times y. 8 times 5 is 40. And divide by 2, so y is 20. Okay, here we have 3 times 2x, that's 6x. And 9 times x minus 3. If you want to skip a step, it would be okay to just distribute this right now and have the distribution written here. So 6x equals 9x minus 27. Okay, so minus 9x, we get negative 3x equals negative 27, and divide by negative 3. So negative 27 divided by negative 3 is positive 9. Okay, and our last question, a small gymnasium contains 10 sets of bleachers. You count 192 spectators in 3 sets of bleachers, and the spectators seem to be evenly distributed. Estimate the total number of spectators. So we can't say for sure that the spectators are exactly evenly distributed, but they seem to be, so we're not going to come up with an exact number, but a good estimate of how many people are sitting in these bleachers. So we counted 192 spectators in 3 sets of bleachers. So how many would there be in 10 sets of bleachers? 192 is to 3 as how many is to 10? So we've got 3x and 1,920. And we'll divide that by 3. And we find there's about 640 spectators in the gym. Okay, and again, that's an estimate. It's not necessarily an exact number because the spectators may not be completely evenly distributed.